Good evening, ladies and gentlemen. Tonight's application problem is going to go over a Rankine oval. A Rankine oval is formed by combining a source-sink pair, each having a strength of 40 feet squared per second and separated by a distance of 12 feet along the x-axis, with a uniform velocity of 10 feet per second in the positive x direction. Determine the length and thickness of the oval. Below the question here, we have two diagrams aiming to explain what is going on in the words above. So, the Rankine oval is depicted in red, created by a source and a sink. These blue streamlines show the flow, and the Rankine oval is the effective shape created by the path of the streamlines. So, on the left, we have a source. On the far left, we have a uniform flow. The velocity is 10 feet per second, so that's a u infinity is equal to 10 feet per second. We've got the x-axis, obviously, and then the y-axis. So we're going to find the length and thickness. Down here, this is also the Rankine oval. Here, A is the distance from the origin to the source or the sink. L is the distance from the origin to the edge of the Rankine circle, oval, whatever. H is the half height. So keep that in mind as we solve for the length and whole height or whole thickness. H and L are half of that. With that, let's get into it. There are two equations we need. The first of which being the distance to stagnation points. Distance to stagnation points. So this is not much of an explicit equation, but it's more of an implicit equation. In fact, both of our key equations will be. We have length over A is equal to the square root of Q over pi u infinity times A plus 1 lumped into this square root. That's one of the key equations we need. The second one is the half height equation. So we've got half height. And so we're going to split that down. Here we have h over a is equal to 1/2 h over a quantity squared minus 1 times tangent quantity 2 times the quantity of pi u infinity a over q times h over a. So here's the two key equations we need, both of which are somewhat implicit. You may be saying, what in the world do all these letters mean? Well, I will define them for you. L is the half body length. Half body length. Pardon my disgusting handwriting. A is the distance from origin to the source or sink. Q is the source or sink strength. And then H is the half body height. So with that, the ultimate things we're solving for is L, half body length, and H, half body height. So I'll box these a little bit, and we're going to say we want this guy, and we want H, just to make it clear. And then we can start out by solving for L explicitly, because we know A. A is given. A is given over here in the 12 feet along the x-axis. We see it over here in the diagram as well. A is half of this. And so, because A is equal to 6 feet, u infinity is known as well, of 10 feet per second. And then Q is also known of 40 feet squared per second. So with all of that, we can solve for it. We can have L is equal to A times this whole equation, which is Q over pi u infinity, a plus 1. We will put all our numbers in where we have L is equal to 6 feet times the square root of 40 feet squared per second over pi 10 feet per second times a again, which is 6 feet. That's plus 1. Drag the radical all the way over. And what we get is 6.606 feet. Keep in mind, this is the half length. And so then the length is 2L for the full length is 2L, which is equal to 13.212 feet. And so we'll box that. That's half of our answer. And the second half we're going to need on the second sheet. So we'll move over to the next sheet. And we are going to redraw our equation. So we have h over a is equal to 1/2 quantity again, h over a squared minus 1, close the first quantity, tangent 2 times pi u infinity times a over q times h over a again. And that's our expression. Now you may be saying, how do we get h from this? Well, it is a implicit equation, which is going to make you want to cry, but we need to solve iteratively. So we have half of this we can guess and check, which is exactly what we're going to do. And so we're going to plug in a value for h over a, which will then be plugged in here, for which all of these other quantities are known. Again, u infinity is 10 feet per second, a is 6 feet, q is 40 feet squared per second, and then h over a is what we're going to be substituting in. So for this, we'll start with an h over a value of 0.2. That's just a guess, just a shot in the dark. Holy guacamole, let me rewrite that. 0.2. We'll plug in 0.2 for all of this, for every other number. What we're going to get is we're going to get 1.477. Okay, we know that's not right. What we're supposed to get is roughly h over a is equal to whatever this right side outputs. So we're going to go, okay, well, that's wrong. What about 0.25? What does that do for us? Then we get 0.46875. That's getting closer. We need to go up a little more. So we'll go up to 0.27. And then we'll go to 0.315. Again, we're getting closer. Let's go to 0.276. And what we're going to get is we're going to get 0.2771. Ongoing. And honestly, this is where you got to say, this is close enough. So with that, we will say h over a is roughly equal to 0.276. We'll just to show that we are somewhat happy, we'll put a big check mark right there to say that's close enough. And we have our expression here. Now we can back h out. So we'll say h is equal to 0.276 times a, which is equal to 0.276 times 6 feet. And what we also want is, because this is the half height, is our full thickness, our full height, is double that, is equal to 2h, which is equal to 2 times 0.276 times 6 feet. And then what that outputs is 3.312 feet. So our thickness is equal to 3.312 feet. And with that, we have both of our answers, and we can say we've defined the dimensions of this Rankine oval. Thank you very much.